Hi, everybody, and welcome back to Chapter 21 in our second video dealing with computing the total cost variance. So here, a cost variance, let's define it, is the difference between our actual and standard cost. Pretty straightforward there. If the actual cost is smaller or less than the standard cost, the variance is favorable. If the actual cost is greater, it's unfavorable. Pretty straightforward. Okay, so what we do here is we prepare a standard cost performance report. And we analyze that. We analyze the variances. We discuss them with knowledgeable people in the plant. And then we take action, which may be a variety of different actions that we can take to take corrective and maybe even strategic actions in the future. So here, the management needs information about the factors causing that cost variance. But first, of course, it must properly compute the variance. In its most simple form, then, the cost variance is simply the actual quantity times the actual price. That's going to be the actual cost. The standard cost will be the standard quantity times the standard price. And then we'll see which one is bigger. And we'll compute the cost variance. Pretty easy so far, right? Okay, so AQ is used for, and SQ is used, and AP and SP are used as abbreviations. All right, so actual quantity, actual amount of direct material or direct labor used to manufacture the actual quantity output. The standard quantity is what we thought it would take, standard amount for both of those. The actual price is the actual amount paid to acquire the actual direct material to direct labor used during the period, and then the standard price is the standard price for that. So let's take a look. First, we'll look at computing the direct materials and direct labor variances. These are the easier ones, I would say. And I have done this many, many times. And it's very tempting for me to take shortcuts once you get the hang of this. My advice and counsel to you is don't. Always do it the way it's described here in this slide. On the left-hand side, we're going to have our actual. On the right-hand side, we're going to have our standard. Okay? And so what we're going to do then in the middle, this is going to be actual quantity, actual price, standard quantity, standard price. But in the middle, we're going to take the actual quantity, and from the right-hand side, we're going to take the standard price. And we're going to compute those costs under those three conditions: actual, actual, standard, standard, and then actual standard in the middle. Okay? So what we want to know is what the price variance is. And how we calculate that is we simply take the actual and compare it to our actual standard. And we'll compute a price variance from that. And that's going to tell us, we have two reasons why we're going to have a material, or for that matter, a labor variance. In this case, price variance is going to be the price we pay for that raw material compared to standard, or the price we have for our wages compared to our standard wage rate. Okay, and that is going to give us our price variance. But we can also use more or less quantity than what the standards suggest. And that's what the quantity variance is going to be. We're going to compare standard over here to actual standard here in the middle. and that's going to give us our quantity variance. This is a very important slide. Be sure that you've got this down, not necessarily from the abbreviations. I always lay it out exactly like this. So if I have actual on the left and standard on the right, that means that my price variance is going to be on the left and my quantity variance will be on the right. And I can do it very accurately and systematically that way. But here are the formulas that are useful to you as well down here. Okay, let's do one here. GMAX is going to produce and sell 35 units, and they used 1,800 pounds of direct material at $21 per pound. Now, this is going to be actual. They actually used 1,800 pounds at $21. The standard is 1,750 pounds. How did we get that? It was 0.5, a half a pound per unit, and we sold 3,500 units. So that means we should have used 1,750 pounds at $20 per pound. Now you can already see, compared to our actual price, we're going to have an unfavorable price variance. I can see that immediately. And also, we're going to have an unfavorable quantity variance as well, because I used 1,800 pounds and I know that the standard is 1,750. So let's lay this out like I showed you in the prior slide. We're going to use actual over here. So 1,800 pounds times $21 per pound gives me 37,800. Over on the right side, I'm going to use standard. Always do quantity first. Standard quantity times standard price. So our standard was $1,750. You can see that that's flexible. That's based on the actual amount that we used here. So you can see why those flexible budgets tie into this theory. And our standard price per pound was $20. So I multiply that through, that's $35,000. Now at this point, what I do is I take the 37,800 actual, compare it to the 35,000 standard, and I'm going to say that's $2,800 unfavorable in total. Now in the middle, I'm going to pick up actual quantity here, 1,800 pounds, and standard price here. And that's going to be $36,000. I compare that 36,000 to 37,800. I'm unfavorable by $1,800. And then over on the standard of 35,000, I'm going to compare that to 36,000. That's going to also be my actual standard is greater than my standard. So that's going to be an unfavorable variance also. Sometimes it's easy to confuse those if you haven't been doing this as many times as I have. So that's why I always calculate the $2,800 first and then compare it to the sum of 1,800 plus 1,000. And then I know I've got everything correctly calculated. All right, key slide here. So how do we evaluate these variances? Who's responsible? I always enjoy this slide because who would you think would be responsible for the direct materials variances? Here, what are those variances? We have price variance and quantity variance. You would think the manufacturing people would be responsible for quantity variance. You would think that the purchasing people would be responsible for price variance, right? So the manufacturing people are saying, hey, I'm not responsible for that quantity variance because you in purchasing purchased this cheap material, so my my people had to use more of it. Now, the purchasing people would say, hey, you use too much material because of poorly trained workers and badly or poorly maintained equipment. I think you could see that that's something you would have to really analyze to get a good feeling for. So if I move this out of the way for a second here, you can see that she's looking at this report that tells us that. All right, let's move this back. Now, direct labor variances, we do that in a very similar way. Here, GMAX produced and sold 3,500 units that we did just a few minutes ago, and we used actually 1,700 hours of direct labor at $33 per hour. The standard is 3,750 pounds, and we got that by taking this 3,500 units times a half a pound per unit. And the actual was $32 or the standard was $32 per unit. So in this case, we are a little bit better in our actual hours that we used. And so let's take a look at that. Here, the actual quantity times the actual rate. 1,700 hours times $33 per hour. And that gave us 56,100. I go over to the right-hand side. Standard hours, that's the quantity, and standard rate. And it's 1,750 hours. This is incorrect here. That should be 1,750 hours times $32 per hour. And that gives me $56,000 at standard. So if I look at this little beauty, in total, I'm $100 unfavorable. So I'll put that in right away. And that's the direct labor variance. Back here, that was the direct materials variance. Now, the wage rate variance, or rate variance as it's called here, is I'm going to put actual hours here, standard rate here, just like I did with the material side. Put actual, and then compare this. I'm $56,100 actual, which is much more than the $54,400 I have at standard. So that represents $1,700 of wage rate variance. And that's very logical. Here we have $32 per hour, but our actual was $33 per hour. And that resulted in a $1,700 unfavorable variance. But efficiency-wise, I was able to make this product a little more efficiently than I thought. So here I'm looking at 56,000 and comparing it to 54,400. I'm a little better than standard by $1,600. So I compare my efficiencies compared to my wage rate, and I find that I'm pretty close to being at standard. And why that might occur, you might have used more expensive labor that's better trained and more efficient, but more expensive, but they produced more. So that's one explanation of why these numbers would be the way they are. Okay. Now, as it says here, one possible explanation of the labor rate and efficiency is the use of workers with different skill levels. Using highly paid workers can result in unfavorable rate variance, but fewer hours might be required. High skill, high rate, low skill, low rate. Okay, that looks like a good place for us to stop this video. And when we come back, we'll look at computing overhead, controllable, and volume variance. Until then, Bye for now.